Okay, so now finally we get to where it's very exciting. This is when we get all the way up to boron. So this is electron number 5. So we already know there's a nucleus. There's a 1s that has 2 electrons. There's a 2s that has 2 electrons. And this electron number 5 has to choose a space that is going to be as close to the nucleus as possible, but as far away from the other electrons as it can get. So it chooses to do something rather spectacular. It chooses a space that's sort of a dumbbell shape, where it's basically going like that. It's going up and down very rapidly, and 90% of the time it's within this space. It can still be other places, but 90% of the time it's moving up and down in this area very rapidly. Since this is energy level 2, this is now a different shape. We'll call it the shape of P, and it once again can hold 2 electrons, as we'll see. This one, notice, is in the y-axis. Well, you would always, of course, realize there could have been one in the x-axis just as easily. So this would be the 2px, and there could be another one coming straight out at you in the z-axis. I'll try to draw it, but it's hard. So it would be going straight back away from you, and then coming straight out toward you, and that would be the 2pz axis. And so there are 3 p orbitals in the energy level 2. They can each hold 2 electrons, because all orbitals hold 2 electrons, and that's total of 6 electrons. So that's boron all the way out to neon. So boron would be number 5, number 6 for carbon, number 7 for oxygen. Notice electrons never go into the same orbital until they have to. So they'll go into X, Y, and Z separately first, and then finally when we get up to oxygen, then we have to finally fill one with 2, fluorine, and finally neon. So this would be the electron cloud model of neon. These are where the electrons are 90% of the time. We can also draw what's called an electron configuration. Let me close the door.